Hey, Math 7. I had a request this morning from a student in first period asking me to go over the try it from example 3 in 8-1. So here it goes. This was a tricky one. This was a good one for you to ask me about because I struggled with it. I also changed my stylus to have the softer top, so hopefully you won't hear as much clicking, but we'll see. Okay, so this is a scale drawing for a barn. The shortest side of the barn measures 150 meters. Maybe this isn't going to work. I think I'm going to have to use the other side. 150 meters. If a new barn that is 2/3 its size, 150, there we go. If a new barn that's 2/3 its size replaces the existing barn, what will the scale of this drawing be to the new barn? So basically what they're saying is right now this drawing represents a barn where this direction is 150 meters. And now they built a new barn and they want to use the same drawing, but the scale is going to be different. Well, here's the deal. Since it's 10 inches and a total of 150 meters, then that means that every inch, 1 inch, is going to be 15 meters. Lots of ways you could figure that out. I'm sure some of you figured it out just by looking at it, honestly. But if you're going from, if it was originally 10 inches is 150 meters, that was originally. If you think about what you need to do to 10 to get it to become a 1, you'd have to divide by 10. So you have to divide this side by 10 also. Well, since we know that the scale of the original is 1 inch is 15 meters, then when you look at the other side, since it's 20 inches, if every one of those is 15 meters, then 20 times 15 will give you 300 meters. Now, honestly, everybody, that's something you probably could have figured out because if you look at the drawing, the short side is 10 inches and the long side is 20. The long side is twice as big as the short. And 300 meters is twice as big as 150 meters. So this is one of those math problems where you could figure it out without using their process. But if you don't learn their process when it's a question that's a little more tricky, you won't know what to do. So this is another one of those times where they purposely start us off with something a little bit easier. Okay. So the scale drawing for the original is what we care about right now, which is this. So now they want us to find the scale for if this drawing was the new barn and the new barn is smaller than the old barn. So an inch is going to be less than 15 meters. So I'm going to change some colors here so you can follow along. I'll change it to blue. If we draw, let's see, I'm going to redraw it down here so that we don't get them confused. This side is still 20 inches. This side is still 10 inches. And they've said the new barn is going to be 2/3 of its size. So 2/3 of 300, 2/3 of 300 is 200. So I know this is going to be 200 meters. And then the long side, or the short side, 2/3 of 150 is 100. So I know this guy is going to be 100 meters. And check this out. You know, that whole thing of the long side is twice as big still holds true on this question. So the new scale, we've got meters to inches. And they were using this originally, so we're going to use this. What we definitely know is 10 inches is equal to 100 meters. and define the scale, we want to change this 10 inches to 1 inch. So what do you have to multiply or divide 10 by to get it to become a 1? You would divide it by 10. So we have to divide this by 10 also. And 100 divided by 10 is 10. So the scale for the drawing compared to the new building, every inch is 10 meters. Okay, so that was example 3.